All right, so now we're going to work on getting the controls to work. So Simon says his thing, right? And that's the objective for the player to do. And then it stops and it's the player's turn. So what we're going to do here is we'll have A be clockwise and B be counterclockwise. We'll need to light up a pixel on the circuit playground to show the player where they are and all of that. So let's go ahead and start with an input for A button and B button. There we go. And we'll zoom into that. Now, what A button and B button are going to do, they're basically going to be the same thing, because one's just going to have the white light go clockwise, the other one go counterclockwise, but pretty much the same thing. So, of course, a really useful thing to do here is going to be to use a function. So let's start with that before we even put any code in the A and B loops here. So let's go ahead and do a function. We'll make a function and we'll call it move player. We're also going to have to take in something. We know we're going to need a parameter because these two things are going to do, we're going to use this function twice and it's going to do something different in each case, right? So if you're ever going to have a function that needs to do different things at different times, you're going to be using a parameter, or what we also call an argument. However, sometimes you don't always know what that needs to be, especially when you're first learning programming. So the good thing is we can always edit that in later. So we know what we want. We know what we want it to do, so we can give it a name, but let's worry about the parameters later. Go ahead and click done. Now, whenever we create a function in this program, it snaps us all the way over to a different part of the screen. So we have to move this over, but no worries. So now we've got move player. And what do we want it to do? Well, essentially we want it to do the same thing that the Cyclone game did, right? We want it to move the circle playground, a white light around the circuit playground's pixels, one direction in one way and the other direction in the other way. So we could basically use the same code that we used for looping it around, which was having a variable, right, for player position. So we'll do that now. Oh, player position already exists, of course, because I've done this code before and I just deleted things. So you would create a variable called player position. I already have it. So I'm just going to set player position at the very beginning of the game to 0, player position to 0. And in move player, we are going to light up the player position light. Set pixel at player position to white. And then what we're going to do, right, if I just put this on a click, by the way, we can see that happen. So I press A and the white light's there. Okay. Of course, we want that here. When we press A, it'll light up the light at the player position. But we know that if we just click on, let's move this into A so we can test it and then we'll move it over. So if we just press A and then increase player position by 1, change player position by 1. We know from when we coded the Cyclone game that what this does change game start by 1. That's definitely not what we want to do. Player position. There we go. Restart that. All that does is grow the white lights around the screen, right? So we don't want to do that. When we press A, maybe the first thing we need to actually do is turn off the pixel where we used to be, right? That's still not working. because it's moved it already when we did that. So what we need to do is actually, let's start with the white light over at player position at the very beginning of the game. Let's set the pixel at player position to white first. Let's see what happens there. So now we start the game. Okay, we're still not turning off the last one like we would expect. So we need to make sure of how we're going to do that. And we're going to do that by changing player position to 1 above the white light, turning on. That way, before we actually increase where the player position is, then we light it up. And the reason why that's different is because, let's work through it in order, right? When we press the A button, we turn off where player position is, which let's say it's 0 at the beginning. We turn it off. Then we increase it by 1. So now it's 1. So we turn off 0. Now it's 1, and we turn on 1, right? When it was where it was before, well, let's think of where it is now, right? It's at 0. But then we light it up at 0, which it already is, which is why it kind of blinks when we do that. And then it's 1. Well, now if we press this, it's going to turn off the light at 1, but the 1's never actually on, right? So it turns that off and then on, never actually turning on the one before it. So look at how one single line, the difference that it can make. All right. So now we know that, though, that we can continue to increase player position, right? So if we console log player position here, and we did this in the Cyclone game, but we'll just do it. We'll just look at this one more time because I think it's useful to debug this kind of stuff, right? So it's at 1 and then 2 and then 3 and 4 and 5 and 6 and 7 and 8 and 9. And now it's 10, 11, 12, 13, 14, 15. So there's no pixel at that position, which is why this is continuing to count up, but it's not lighting up any of these lights. So we have a pretty big issue there, right? So what we can do is if, zoom back in a little bit, we'll do our if statement where we say if the player position is greater than 9, then we set player position back to 0. This is the exact same thing that we did with our Cyclone game, except now we control the light. Oh, if its player position is greater than 9, we need to do that before we turn on the white light, of course. There we go. Okay. Now we can go ahead and throw this in here, except now we need to think about what's going to be different from A and B. We know that on A, we want the light to go around the circuit playground clockwise. So we need to increase this by 1. So this will be a -1 for B, right? So there's one parameter. We know that this needs to not be greater than 9, but needs to be less than. So this is different. Less than 0. Then we put it to 9. So this number, this Boolean right here, and this number. So we need 2 numbers and a Boolean. So let's go and throw this in here. And let's do that. Right click, edit function, number, Boolean, number. And remember that the first number is what we're going, how we're moving it. So we'll just call this move because it's how we're moving. We're either moving it down or moving it up, increasing or decreasing. The Boolean, we're checking for if it is off of the array of lights on Circuit Playground. So we can call this is off array. Because if it's off the array, we're resetting it. And that's actually a good name for this number right here. If it's greater than 9, we reset to 0. And if it's less than 0, we reset to 9. So this can be our reset variable. Move goes here. Is off array goes there. Throw that away. And reset goes there. Now these variables, right? One thing we need to know about functions is variables can be global, like variables that we've created here, like level or player position, or they could be local, like move is off array and reset. In other words, these variables get made when the player function is called up here, and then they get deleted when the function is over. I can't use move anywhere. Notice that I can't put that into where 1 is because only this function sees it. All right. So now that we have our move player function, let's go ahead and call it in A and B. So call move player on A, and we don't need a comment. Call it probably would be good if we commented our code, but we're not going to need to for this. So move player on A, the move is going to be 1. We just said that. And on B, it's going to be -1. For the reset, after we find out if we're off the array, this will be greater than 9. So we put it to 0. This will be less than 0. So we'll put it to 9. And now the Boolean, of course, will be if player position, and this is what we just said, if it's greater than 9, we do our reset, and I can duplicate that because if it is less than 0, then we move to our reset in when we press the B button. All right, now let's test this out. Refresh. A all the way around. B all the way around. And notice something interesting. This was working just fine with the exact same code earlier, but now I'm pressing A here and B, and for one moment it's off of the Circuit Playground. The is off array for some reason isn't working, even though it was exactly the same before. And let's console log this just to see why. What's happening here? Player position. Remember that player position should never be greater than 9 if I press A. Let's see what happens. A. Open up console. So 4, 5, 6, 7, 8, all less than 9. 9. 9. You know, it's not. 9 isn't greater than 9, so that's fine. But when I press A, 10 is greater than 9. But player position, the Boolean shouldn't let player position be greater than 9. It shouldn't let it be 10. How is that even possible? Well, what we were just saying with the scope of variables, how, we have these local variables and they can't go outside, right? I can't move this anywhere and put it in here. So I can put global variables like player position inside this function. However, while it's inside the function, when I test it with a Boolean, it's going to remain what it was when we started the function, right? So when player position enters this function at 9, and then we increase it to 10, and then we check, is player position greater than 9? This Boolean does not understand that player position just got made 10. It thinks it is still 9 because we changed it inside the function, not outside the function. So we are going to have to, we're going to have to edit our Boolean here to make this work. And we can do that simply by saying, is it greater than or equal to 9? Same thing with this one. Is it less than or equal to 9? And now that should work just fine. So let's refresh. Press A. We can open up the console log. Now 1, 2, 3, 4, 5, 6, 7, 8, 9. Back to 0. And same thing with B. All right, it's at 2. Now it's at 1. Now it's at 0. Oh, I'm not console logging. I'm not console logging it, but you can watch it just happen. Now the reset works perfectly. Go back. All right. I can throw this console log away now that I know that that works. I can move this move player function over to the rest of the functions. We could work on our next thing. So we just got clockwise and counterclockwise taken care of. So now we need basically the core functionality of our game. When we select a pixel using AB, we need to check a few things, right? When the player selection is made, check randoms to see if it's correct. If it is, and there are still more selections to make in that level, then we need to move up to the next item in random nums, right? So that we can check every number in the level. If we're right, but there are no more selections to make, right? We're at the end of the level, then we increase the level and we have Simon show the lights for the next level. If it is and there are no more levels, we're at level 10, right? We show the winning lights, we reset the game. And of course, if it isn't, then we've lost. So let's go ahead and make another input here. And we'll do that as A plus B. And we will go ahead and start checking some stuff, right? So we need to know if the player is right. Keyword there being if. So we're definitely going to have to start with some logic. If true, then. So we'll worry about the Boolean later. What inside of here needs to happen if we are correct? We're going to assume that the player is correct, right? So if they're correct, we need to first check if there are still more, if there's still more lights to go. So we're going to need another variable, right? So we have level, but we don't have a score variable. So let's go ahead and create a score variable, which of course I already did here. So you're going to create the score on your own and make sure we set score to 0. And if we're right, we're going to increase score by 1. Change score by 1. And how are we going to know if we're right? Right? So we're checking the randoms is what we're doing. So if we pressed A and B, then we can say if score, right? Because our score will start at 0 at the game at the beginning of the game, and our first position of randoms, right, is going to be, so with this we're assuming that the first correct answer is the light being in the 2 position, right, which is at index 0. See there? Am I still on blue? I am. So if score is 0, right, because now we can add score to this list of arrays that we have. Although score won't really be an array. It's really just something that's going up each time. So I guess maybe we shouldn't add that as an array. But regardless, score is going to start at 0 when the game starts. and randnums is in the 0 position. So that's exactly what we want to be checking for. Then we can increase score and check each one. So if score is equal to, or I'm sorry, if the player position, because that's the light that we're going to be on, if the player position is equal to arrays list get value at randnums get value at score. If player position is equal to in the randnums array get value at score, then we change score by 1. So now we have a game where we can at least do the first level. Of course, the game doesn't know that we've done anything yet, so let's just put, well, we're not going to want to increase the level yet, because that's actually the next good thing to start at. How do we know that the level's been beaten, right? So we change score by 1, but then we need to know that the level's been beaten. So we're going to go ahead and do another if statement. And if the level has been beaten, then we're going to want to increase the level by 1. And if we beat the level, we need score to go back to 0 again, right? Because each new level, you start the score at 0, because in Simon, you have to play the sequence from the beginning every time. You don't just have to remember the last light. That would be way too easy. So we want to set score back to 0. Oh, this isn't change by. We want to set to. There we go. Set score to 0. And how do we know if we beat a level? Well, if score is ever equal to level. And why would that be? Why would this make sense for beating the level? Well, and why would it not be if score is greater than level? Well, let's imagine that it's the first level again. Let's go back to our arrays here. So score, if score is 0, the game is at 0, randnums is at its 0th position, and it's going to light up 2, right? Remember that lighting up 2 will be light green, a light green light at the second pixel position, playing that E note on the piano, and that lights up, does its little beep, and now you have to go over to that second light and press A and B at the same time. And now score goes from 0 to 1. So now score is, oh, I may be wrong. Did I say equal to level? Level's going to be 0. Oh, I was wrong. Oops. Score, if score is ever greater than level. I just talked myself out of my own logic there. But regardless, now that makes sense. See, sometimes it's always good to say code out loud, because even I make mistakes. So now we can talk about this the right way. So score is 0. The 2 lights up. We move over to 2, pressing the button. We press A and B, and it's correct. So now score becomes 1. Level is still at 0. So is 1 greater than 0? It certainly is. So now we're on to the next level, which then level would be 1. Score is at 0, so we have to go 2, right? Simon shows 2 and then 8. So we go over to the 2 and we press A, B. Score is now 1, but level is 1, and 1 is not greater than 1. So we still have to do the 8. We go over to the 8, we press A, B, and we're correct. And now score is 2, level is 1, 1 is greater than 2. We're finished with that level. So now this makes perfect sense. So now let's see if we can play this game. Okay, so the first light just lit up. Wait, hold on. Let's completely refresh that. There we go. So this light, press it. Nothing happens because we never set player ready back to 0. So let's do that. Variable, set player ready to 0, which is what we're going to have to do when the game is, when each level is over. There we go. So we go over here. And there we go. And let me turn the sound on so that you can hear this as well. And there we go. Light. And so on and so forth. Now, we are missing a little bit of feedback here. So we're going to stop here. We're going to go to one of these extras, because I wouldn't even consider this an extra. This is pretty much mandatory. Some player feedback. When the player selects a pixel, it should light up that pixel and play the correct sound. Also, I don't like that the player's light lights up right at the beginning of the game, which we did with the pixel color being at the bottom here. Let's put this at the end of when player is ready. So right before player ready is set to 1, let's turn on the light. All right, very good. So if player position is, so every time so this is when we're correct. Let's basically steal from objective here. Actually, we'll have to, I think it'll be better to just do this on our own. So what we're going to want to do is we're going to want to light up a light and play a sound. And of course, we're going to be lighting up the light at the player position, because if we're correct, if we got the answer correct, player position should be the exact same number as the correct light. Because we could put in here also, randoms, get value at score. We could do that too, just like we have here. But player position works as well, because remember, this is only going to trigger if these two are the same thing. The color that we're going to want to get is going to be the color that we get here. Simon colors get value at random nums, get value at not index, because this isn't a loop, but instead at, of course, score. And we're going to do the same thing we did before by being very lazy and copying Simon colors and just changing that to Simon sounds, putting that in there. Okay, now we can refresh. Okay, so when we beat a level, it's way too fast for us showing the next level. Also, let me double check one thing as well. Yeah, our light stays lit there. We probably want to change that back to the player position white light, which was over here. As soon as we're done playing that sound, let's see how that looks. We have to get to the second level to test that. There we go. Much better. Okay. So let's add a delay here. So we're going to need a delay variable. Oops, I forgot I already have these delays, these variables named already. Set delay. We'll do 500, half a second, 500 milliseconds. Put that delay right before we set the player back to 0 there. That's going to be loops, pause, by, delay. That's much better. Okay, so we basically have this entire game made. We just don't have the ability to do to check if we've lost. So we're just going to wrap up with that now. And the extras, we will either do those in a completely different video, but probably a little bit later on, because I didn't do all of the extras in class, only with classes that finished up a little early. So this video doing on that isn't a priority for me right now. So we want to, well, first off, AB selects pixel. So we finished that. And if there's more than one selection to make, we basically did all of the wins, right? If there's more selections to make, move on to the next. Increase the level if there aren't. Oh, we didn't do winning and reset. So perhaps I will end this one right here, actually, right at, this one's about right at a half hour just now. So let's stop here and I will do winning. I'll do the resetting and the losing in the next video, which will probably be a lot shorter than the first two. All right. I will see you on the next one.